Hello everyone, today we're going to be working on example 5-3, and this example is asking us to calculate the reaction of the beam loaded as shown. So as you guys can see here, we have at point A, we have a pin support, knowing that we're going to have a Y reaction. I'm going to assume upwards, and then we're going to also have a X reaction. I'm going to assume acting to the left. From there, we have our 500 newtons acting downwards 3 meters away from point A. And then we have a rope right here. So the first thing that I'm going to do is I'm going to replace the rope with a tension force. So we have this rope right here. So we're going to replace that with a tension force. So let's determine the values of those tension forces. So we're going to have a tension force going upwards. This is going to be, we're going to be able to determine this by multiplying 3/5 times the tension of BC. I'm going to be calling it BC because it's at point B, and I'm just going to be calling this also pin support C, so tension at BC. And then for our horizontal tension, we're going to be able to determine its value by multiplying 4/5 times the tension of BC. So now that we know that, what I'm going to do is I'm going to be taking the moments at point A, because that way if I take the moments about point A, we're not going to get a moment created by the reaction AY nor AX. And that's going to help us determine the value of the tension BC. So if we were to take the moment about point A, we know that the moments about A have to equal 0, like we mentioned earlier. AY and AX will not be creating a moment. So from there, we have our 500 newtons that's on the right, acting downwards. So we know that's going to be creating a clockwise moment, meaning negative moment. So we have a negative moment of the force, 500 newtons, times the distance, which is 3 meters. From there, we have our 3/5 times 3/5 TBC. We know that's going to be creating a counterclockwise moment since it's to the right acting upwards. So that's going to be a positive moment. So our force is 3/5 the tension of BC. The distance is 5 meters. And then from there, the 4/5 times the tension of BC will not be creating a moment. So these are all the forces that are creating a moment about point A. So we know all that has to equal 0. From there, we get 3/5 TBC times 5 meters is equal to 1,500 Newton meters. From there, if we solve for TBC, we end up getting that TBC, the tension at point BC is equal to 500 newtons. And then the direction, this is the direction. So now that we found the tension for the rope BC, we can now plug in that 500 into each of these equations, giving us that the vertical tension is equal to 300 newtons. We know that's going to be acting upwards. And if we were to plug in the 500 newtons into the 4/5 times the tension of BC, we end up getting 400 newtons acting to the right. So now what we're going to do is we're going to be determining the value of the reaction AY. So anything going upwards is positive. We know that the sum of our forces in our y direction have to equal 0. So we assume that AY is acting upwards, so that's going to be positive. Then we have negative 500 newtons since that's acting downwards. And then we have the positive 300 newtons that because of we replaced the rope with a tension force. So that's going to be positive. So we have positive AY minus 500 newtons plus 300 newtons. We know that all of that has to equal 0. So we end up getting that AY is equal to 200 newtons. We ended up getting a positive number, meaning that we guessed correctly. So we do know that AY is equal to 200 newtons acting upwards. And then from there, we now have to determine the value of our AX reaction. So to find the value for that, we're going to be taking the sum of the moments of the sum of our forces in the X direction. So sign convention, going to the right is positive. The sum of our forces in the X direction have to equal 0. So we assumed that our A of X is going to the left, so that's negative AX. And then from there, our only other force in the X direction is our 400 newtons. We didn't assume, sorry. We know that that tension force is going to the right, so that is a positive force. So plus 400 newtons has to equal 0. So if we solve this for A of X, we end up getting that A of X is equal to 400 newtons. We got a positive number, meaning we assumed correctly. So we know that that 400 newtons is going to be going to the left. And now simply to make sure that we calculated all of our reactions correctly, what you could do for a quick check is now, instead of taking the moments about point A, what we're going to be doing is we're going to be taking the moments about point B, meaning that these two forces are not going to be creating a moment. So let's check that real quick to see if we calculated the reactions correctly. So we know that the sum of our moments about point B have to equal 0. So this statement has to be true. So we have, if we're taking the moment about point B, we have this 500 newtons acting downwards. We know that's going to be creating that counterclockwise moment, meaning it's going to be a positive moment. Its distance is 2 meters. So we have positive moment of 500 newtons times the distance of 2 meters. And then from there, our reaction AX is not going to be creating a moment. So from there, we only have AY. We know that's going to be creating a clockwise moment, meaning it's going to be a negative moment, and the distance is 5 meters. So we know that our AY has a value of 200 newtons. Remember, we said that this is going to be a negative moment. We have 200 newtons. We said that the distance is 5 meters. And we know that for it to be true, that we calculated our reactions correctly, it has to equal 0. So we end up getting 1,000 Newton meters minus 1,000 Newton meters has to equal 0. And we end up getting that 0 is equal to 0, which that is correct. So that's just a quick way on how you could do an independent check. So if you took the moment about point A at the beginning, at the end, what you want to do is you want to take it about point B, and vice versa. If you took your moment about point B in the beginning for other examples or other problems, then in the end, you're going to want to take the moment about point A to just do that independent check to make sure that your reactions are correct. Thank you guys so much for watching this video. Please feel free to like this video, and also please feel free to subscribe to our channel if you guys would like to see more videos like this.